Welcome everyone who's joined the webinar today so far. I'm just going to give it a minute or two just for people to join and get logged in, okay? But delighted for those of you who are online that you can join today. I'm Laura Broderick. I'm the Head of Partnerships and Programmes at the Building Centre. So I've been working on the Retrofit 25 programme, of which this webinar sits under. I can see a few more people are joining, which is fantastic. So just while we get a few more into the Zoom, just to introduce Retrofit 25. It's our major exhibition and event series running through till the 19th of September at the Building Centre on Store Street in London in collaboration with the National Retrofit Hub. For Retrofit 25, we've been looking at the topic of what's stopping us and themes under that we need to address in order to enable the scaling piece of retrofit and action today. So delighted that we are running in-person events and also webinars, also these retrofit talks. The topic today is alternatives to radiators and underfloor heating. And we've got DiscreteHeat, one of our retrofit partners, talking today on that particular topic. I hope everyone can hear me nice and clearly now. So as I said, the webinar today, our retrofit talk for today, is alternatives to radiators and underfloor heating with DiscreteHeat. And I'm going to introduce and welcome Ethan Wadsworth, who will be delivering the webinar with us today. So if Ethan could come on camera, that would be fantastic. And for our attendees, I'll introduce Ethan before he gives his presentation. After his presentation, there will be time for Q&A, and you can put your questions to Ethan through the chat box, the Q&A box function at the bottom of your screens. So do start to think about the questions you might like to put to him, all about the ThermaSkirt system that he's going to explain. So for now, Ethan Wadsworth is a director at DiscreteHeat, the company behind ThermaSkirt, a skirting board heating system designed to make low carbon retrofit simple, practical, and scalable. Ethan leads the company's strategy to support the UK's transition to heat pumps and low temperature heating. He's passionate about decarbonising homes without disrupting lives, and he works closely with housing associations, installers, and policymakers to drive practical innovation in retrofit. So it's fantastic that he could join today and say more on this topic. Just so you know, ThermaSkirt is featured in the Retrofit 25 exhibition. There's a fantastic case study, and also the actual product is installed within our demonstration space. So if you are able to visit Retrofit 25 in person, you'll get a chance to kind of see the product in action. So I'm going to hand over to Ethan now. He's going to talk for about 20 minutes, and then I'll come back on camera for Q&A. So as I say, remember to put your questions in the chat box, and we'll get to those after Ethan has presented. So over to you, Ethan.
Thank you very much. I will just quickly share my screen. Thanks for the wonderful introduction. Obviously, I couldn't have said that any better myself. So yeah, the aim of today is to introduce everybody to ThermaSkirt as an alternative to radiators and underfloor heating, but primarily explain why it's one of the solutions to the what's stopping us question. Ultimately, everybody agrees that net zero is the right way forward, apart from some political parties, obviously. And everybody agrees that heat pumps is the way that it's going, obviously, from a legislation perspective. That's certainly the case. One of the challenges around that, of course, is all of the ancillaries, and that's what we're presenting here today. So the product that we manufacture here in Manchester, in the factory that you can see behind me, is a product called ThermaSkirt. And ThermaSkirt, well, you're looking at it here on screen now, I hope. And ThermaSkirt is effectively an aluminium radiator that has been squashed and stretched and disguised as a skirting board. Now, whilst that's obviously quite a cute aesthetic benefit, there are a number of significant benefits to retrofit in particular, and local authorities and developers that wouldn't necessarily be immediately obvious from looking at it. So just to cover off some of the key benefits of the product, obviously aesthetics, which I've mentioned, when you take into consideration radiators and the size that radiators will need to be on heat pumps, underfloor heating and skirting board heating both resolve that issue. The other major benefit is usable room space. Eliminating radiators from walls typically saves about 1 meter squared per room, which if you factor that over the whole size of the house, you could effectively save an entire room worth of space by freeing up the walls. And then obviously efficiency. So when you come to lowering flow temperatures, which is what we have to do to meet net zero targets, you increase efficiency. Lowering flow temperatures increases efficiency, but unfortunately, lowering flow temperatures also means you have to increase your emitter size, which means radiators have to increase by a factor of 2 or 3. The other angle, of course, is the perception of lifestyle benefits. So one of the serious things that's holding heat pumps back at the moment is that to the actual consumer, to the end user, they don't fully present any kind of lifestyle benefit. And we always make the joke that if the government had a £7,500 grant on hot tub sales would absolutely skyrocket. But because heat pumps really are either misunderstood or they involve lots of other additional disruption, which I'm going to come on to, they don't actually offer any perceived lifestyle benefit, and that can create resistance to the rollout. The other upshot of putting heat pumps into retrofit situations is the amount of work that's involved and the disruption within properties, which I'm also going to address today. And then finally, reduction in complaints. So particularly for local authorities, a major barrier is the concern around having additional complaints, whether that's that the radiators aren't hot enough, that the heating system doesn't respond quick enough. And yeah, ultimately that creates fear and obviously ongoing cost to adopting that kind of innovation. So in terms of the housing stock in the UK, the UK has one of the oldest housing stocks in the world, effectively, particularly the publicly owned. So there's a whole range of steps that need to be taken in order to make existing housing suitable for heat pumps. Obviously, improve insulation, which is a well-known and a standard consideration, and not obviously something that we address with our product, but there's plenty of other products at the building centre which do. Hot water storage, again, with heat pumps, you need to store your hot water somewhere, whether that's in a heat battery or whether that's in an actual physical hot water cylinder. And the bit that we help address are the radiator sizes and the pipework and the disruption. There's two things to that. One, obviously, is the radiators need to increase in size. The other element is microbore pipework, which limits, particularly in retrofit, the suitability of heat pumps because you can't deliver the same amount of heat down a 10mm pipe than you can down a 15mm pipe, for example. And that means that from a retrofit perspective, there's a huge amount of work that needs to be done to retrofit new pipework into those spaces. And ThermaSkirt helps address that. So firstly, if we look at radiator sizes, so if you, just to make it easy, I've highlighted where a typical bedroom and a typical living room would be, and the heat loss of that room. So about 600 watts for a bedroom and around 1 kilowatt for a typical living room. And these are the equivalent radiator sizes that you'd need on a low temperature system. So to hit that 1 kilowatt, you'd need a 2 meter long by 600 high K2 radiator, which is seriously impractical and not only creates physical constraints for designers, but it also creates psychological constraints because people simply don't want to look at something that's so big and obtrusive. The alternative to going long is to go deep. So you can have K3 radiators, for example. But regardless of whether it's long or deep, a radiator of that size is also incredibly heavy. So a 1 kilowatt radiator on a heat pump will have a wet weight of around 95 kilograms. So it's the equivalent of hanging, a small motorbike on the wall. And often in retrofit, you're fixing onto materials and fabric that may not be able to take that kind of weight. So in terms of how that works with ThermaSkirt, ThermaSkirt is effectively just a radiator and it's plumbed into a standard central heating system, exactly like a radiator would be. So whether this section here is a heat pump or a boiler, obviously in this instance we've used heat pumps, you have a standard flow and return pipework distribution setup, and that pipework tees off directly to the ThermaSkirt, and each room of ThermaSkirt is individually controlled. So as far as the first fix plumbing is required, as far as the system design that's required, and water volumes, everything is the same as a radiator. effectively, the ThermaSkirt is just a radiator that's been squashed and stretched. And that brings us on to the disruption and what is actually involved in retrofitting heat pumps. So Energy Systems Catapult did a study into the barriers to installation of heat pumps. And 68% of participant dropouts, so these are people who have indicated the need to install heat pumps, but subsequently dropped out, was down to disruption. You've got practicality issues, so space, noise, time taken to do the installation, technical issues, and then economic. So economic was 4% of homes, effectively meaning that it was either too expensive or too expensive to run. Personally, I don't actually believe that 4% figure. I just think that if given the option, most people will choose something other than, I haven't got enough money to do it. But even if you factor that out and say that economic is 30%, disruption and practicality make up a huge proportion of the resistance and the dropouts on heat pumps. And that's something that we aim to address with our ThermaSkirt system. So here's a prime example. So this is a first floor of a typical 3-bedroom semi-detached house. This is, your bog standard 1930s semi. And you can see, for example, where the radiators are always located. And this is something that people don't always take into consideration. The radiators here are located under windows, so they're always positioned at the extremities of the room. Now, when you're installing new pipe work, so in this instance, putting an entirely new central heating system in, you have to get the pipe work from typically a central location to the emitter. And on the left, you can see that we've got the pipe work running out to the radiators, and the yellow zone is the area of disruption that's required. So in this instance, it's removal of furniture, removal of floor coverings, lifting the floors up and drilling through the joists to get pipe work from the center of from the landing to the extremities of the room. With the ThermaSkirt, which you can see on the right, we can connect into the pipe work wherever's necessary. So there's a huge reduction in disruption, basically 75% reduction in disturbed areas, which means that you don't even need to take furniture out of that space in order to retrofit that system. So when trying to do a little bit of open heart surgery and get a heat pump into an existing property, systems like skirting board heating really open up that opportunity without causing a huge amount of ongoing cost. A secondary application is that skirting board heating can often be used to supplement existing systems as well. So obviously we frame our solution as an alternative, which it is, but many people don't realize that you can actually supplement existing systems with ThermaSkirt. So in this instance, when switching from a boiler to a heat pump, this radiator would no longer be sufficient to meet the heat loads, but it is doing something. It is meeting a certain level of heat output. And the ThermaSkirt can be used to make up that shortfall. So if, say, for example, that radiator was short of a heat output by, say, 300 watts, we could install 4 meters of skirting to make up the shortfall on that. And again, that minimizes cost, minimizes disruption, and it means that you can practically install a heat pump without having to sort of throw the baby out with the bathwater. A secondary benefit, of course, is thermal comfort, which ultimately is all anybody cares about when they move to a heat pump. One of the things that creates resistance with innovation is early adopters having negative experiences. So if people who are early adopters move over to heat pumps and they don't feel comfortable, regardless of whether that heat pump is delivering sufficient energy or not, it doesn't really matter because the personal perception of how comfortable that makes their space is ultimately what's going to drive their opinion. So this is the example from our BizRIA test data. And this is a 4 meter by 4 meter room. And this slide just sums up in one image why ThermaSkirt is a more suitable emitter at low temperature, because the room on the left has got 800 watts being delivered by a radiator, and the room on the right has got 800 watts being delivered by skirting heating. So the exact same energy input, the same heat distribution, the same heat loss, and for the exact same energy use, you get totally different results in terms of the actual thermal comfort. And in this situation, ThermaSkirt is much more like underfloor heating than a radiator in terms of its thermal comfort. But of course, from a retrofit perspective, underfloor heating would be a major operation and a major expense to retrofit, because you have to change the doors, you have to remove all the floor coverings, you lose ceiling height, and often you have to do overlay boards and expensive systems like that. So ThermaSkirt really does come down the middle as a simple solution like a radiator, but a comfortable and practical solution like underfloor heating. And we very much sort of position ourselves in between those two as that alternative. Safety and accident prevention is obviously a major concern for local authorities and high-risk environments like care homes, for example. So for a lot of domestic customers, safety and accident prevention, whilst it's important, it's not always the primary concern. But interestingly, 87% of radiator-related injuries are actually impact injuries. So this is people falling onto them, dropping them, and effectively things that skirting board heating eliminate straight off the bat. Mold and damp is another impact as well. So one of the considerations to make when making radiators larger is that when you make your emitters larger, you effectively give people more space to dry clothes on. And that is a major contributor to excessive moisture within the environment, and excessive moisture ultimately leads to mold. Now, obviously, this year we've had AWAB's law introduced, which aims to reduce the propensity of mold and damp in the space, and effectively legislates that local authorities have to deal with it quickly. So we find that adding measures to eliminate it at source make a lot more sense long term, because they have no ongoing maintenance requirements. One of the things that I'd love to share after the presentation is the full detail of our retrofit case study with Wigan. And this is a prime example of a 1950s end terrace that's had external wall insulation, solar, heat pump, and ThermaSkirt added. And the purpose of this retrofit was not to fall into the trap that many pilot schemes do, because often pilot schemes begin as quite a practical plan, but then they start to grow arms and legs, and they sort of become totally impractical because of the amount of measures that are being added. What happens is that the local authority can get carried away, and they start to want to make the house the best it could possibly be, as opposed to the best thing that they can practically roll out. And our project with Wigan was to really hone in on a specification that can actually be rolled out at scale, and works well at scale, because everything makes sense. You're improving the building fabric, you're generating energy with the solar, and then you're minimizing your heating and hot water demand with the ThermaSkirt and the air source heat pump. So I'd love to share the PDF of that case study afterwards and show you the results. Secondly is the results from Energy House 2, which were published earlier this year. And this, for anyone who's not familiar, is the testing facility in Salford, run by the University of Salford, where they have a weather chamber in there. They can test houses down to -20. And ThermaSkirt is now independently verified as the most efficient heat source on that specification. So in comparison on running costs to the alternatives. And hopefully this will address some of the questions that we get around kitchens. Obviously, I can't see you or hear you at the moment, but I imagine some people will be asking what happens in kitchens. So skirting, heating, I mean, ThermaSkirt as a product is ultimately primarily a skirting board, but you can see here that we also have some smart solutions like kitchen plinths and also threshold heating. So glazed areas are the area of greatest heat loss. You can see here we actually colour match it to the windows, and we either drop it into the floor covering or we fit it over the floor covering. But effectively, we create heat where it's needed most to not only continue to spread heat around that room, but also to offset the heat loss and improve the comfort of that space. In terms of how we help local authorities and housing associations roll out systems like ThermaSkirt, is we use our online education platform to basically bring people up to speed on how the product works, how it gets installed. But of course, we do practically support that on site. So if there's DLO installation teams, we support that with our own labour. We have over 100 companies across the UK that supply and install ThermaSkirt as well, and a number of these contract directly for house builders, local authorities. And where we are now is sort of plumbing and heating's best kept secret, as we like to call ourselves. So for many people, we're new, but for many people, we're not. We've been around for 15 years. We are working with some of the UK's biggest housing developers, and we're also available through a whole UK-wide network of distributors. So one of the things that I would like to do is invite in some questions. If anybody has them in the notes, Laura can ping back in and manage this for me.
Great. Thank you so much, Ethan. Appreciate that was a whistle-stop tour of your journey as DiscreteHeat, setting up the kind of the launch of ThermaSkirt and putting it to market. So it's fantastic to hear. If people wanted to find out more, they can obviously contact you. You've got your email address there, but you're right, we do have time for questions. You will be pleased to know that people have started to put their questions in the Q&A box. But if anyone else does have those to address to Ethan, please do type them, and then I will kind of present those to Ethan as a kind of conversation between him and I for the next sort of 10-15 minutes or so. So yes, Ethan, let's just get started if that's all right. So question in from Iwona, does the ThermaSkirt work with a combi boiler where there's no water tank?
The short answer to that is yes, it does. So most of the systems that we install are actually on combi boilers, and one of the key benefits of that is that you can actually turn the boiler down. So one of the things that we're rolling out with local authorities at the moment is actually making properties heat pump ready. So you take the existing combi boiler, you will turn the flow temperature down to 45 degrees, and we'll size the system accordingly. And yeah, effectively it just runs like an ordinary radiator, either at high temperature or low temperature. But obviously we aim to run at low temperature in order to minimize the energy use.
Great. Thanks, Ethan, and thanks, Iwona, for the question. Next question in. Obviously, the title of this event was around an alternative to radiators and underfloor heating, but this person is asking, can you use ThermaSkirt in conjunction with underfloor heating?
Yes, you can. So a number of the new build specifications that we do has underfloor heating on the ground floor, and they use ThermaSkirt upstairs. So effectively, we are just another emitter for that space. A number of developers at the moment are doing underfloor heating downstairs, and then they kind of compromise on the first floor and do radiators. So we offer that no radiator solution if you've got, carpets like I've got in here, for example. As soon as you've got thick carpets, underfloor heating upstairs can become a little bit impractical. If you've got very hard to heat retrofit environments, you can actually use both systems together in the same space. So we've done some churches, and we've done some sort of large halls and open plan spaces where underfloor heating on its own wouldn't be sufficient, and ThermaSkirt on its own wouldn't be sufficient, but we can combine the two solutions and basically double the output and still not have any radiators.
And sorry, Ethan, I'm just going to pick up on that. How would that be assessed? Is that the role of DiscreteHeat? Do you help kind of think about the needs of that space and heating that space, or is that sort of a retrofit assessor's done some work and then you kind of come in and work with them? How would that flow, Ethan?
So we have a full in-house design team, basically. So what generally happens is people with projects, whether it's consultants, architects, local authorities, or just property owners,
An individual.
Yeah, individuals. They approach us with their project. They send us floor plans of the project, and our in-house design team do a detailed heat loss calculation. We assess exactly how much ThermaSkirt is required. If we can hit the requirements on our own, which in 95% of instances we can, then great. And if we can't, then we flag that up, and we basically propose a full solution that will be that within the floor or radiators.
Right. Okay, back to the audience questions. This one's quite a long one from Agatha. What is the minimum required depth and height of the skirting board to accommodate the pipes behind it? If ThermaSkirt is installed as additional to a standard radiator, for example, just on one side of a room, how does it then connect to the combi boiler, for example?
Okay, good question. So, one of the misconceptions with the ThermaSkirt is that there is pipes. You put pipes behind it, which you don't. So the ThermaSkirt itself, the panels themselves, actually have the pipes built in. In fact, actually, if I stop screen sharing, I'll be able to show you. I just stop that. So you can see this is a piece of skirting here. So
Yeah,
this is in long length. So you can see down there on the shelf, we've got 4.5 meter length of this, and the pipes are actually integral. So you basically cut this whole profile and you connect onto standard 15 mil pipes with our connections. And these pipes are oval, so you've got a very, very slim profile. So the profile itself is only 20 millimeters.
nice.
Yeah, so it's the same depth as a standard skirting. And then we do different heights and different designs to basically A, meet the heat loss requirements, but then B, also meet certain aesthetic requirements as well, whether it's a more traditional looking profile or, a modern sort of square edge like this.
Mm. So there's options within that. Yeah,
Yeah,
great. All right, Ethan. How are you doing on this? So there's quite a lot still coming in. We've got 11 in the boxes here. So
that's
right,
fine.
you're
You
okay.
basically this has been the last 15 years of my life. So this is like
Okay,
hitting cabbages with a baseball bat for me.
right. I'll roll with that. Okay, so next question. How much and what type of insulation is placed between the ThermaSkirt radiator and the wall so that heat loss through a likely uninsulated wall is minimized? So I suppose that's that whole kind of fabric approach to how does this work with everything else that's going on?
Yeah, so as standard, actually, I've not got a sample with me, but as standard, behind the skirting, we supply a membrane. So there's a membrane that's made in the UK by a company called Glidevale, and effectively it's a breathable but reflective membrane. It's very, very thin. It's like the same thickness as a piece of foil, and you get a meter of that per meter of skirting. So in the box with the skirting, you get the insulation foil, and what happens is you fit the foil to the wall, you fit the brackets onto the foil, and then the skirting fits onto that. And that minimizes the heat loss basically into the wall. So if you've got in new builds, it's not so a problem because the fabric is good. I mean, we supply it anyway, but you are right. It makes the biggest difference in retrofit when you've got, very poorly insulated walls or solid walls. So yeah, it's very, very thin and it comes with the system as well.
Great. A couple of questions around that installation process, because obviously you said at the beginning this aims to be as low disruption as possible, and that's what
Yeah.
consumers want. And so that's kind of, your starting point for getting this product and getting interest in it. But a couple of questions on that. Um, so you've said that furniture won't have to be moved, but how is that possible? I think basically someone's talking about logistics of it. I mean, obviously there has to be some disruption, but it's minimal disruption, right? I mean, there is obviously going to be a
Yeah,
process of people in and installing and yeah,
think it might be misunderstood there.
yeah,
But furniture definitely has to be moved.
yeah.
Definitely. So
And
you
as I
definitely have
was
to
reading
move
it, I
it.
was thinking,
You,
okay,
you,
so
you don't have to remove it. So
yeah,
when you install underfloor heating, you can't install underfloor heating in a room that's got anything in it. You have to remove not only the furniture but also all of the floor coverings.
mm,
So from a retrofit perspective, it's it's more of a refurb job than it is a retrofit. So for many customers, for many of our domestic customers, we literally just install the ThermaSkirt and that's it. So installing the ThermaSkirt, other than painting the patch of wall that was behind the radiator, is the only thing that they're doing.
yeah,
So it doesn't have to be part of a deep retrofit. It doesn't have to be part of a renovation project. You can literally within a few hours, remove the radiator, remove the skirting boards, and connect onto the existing pipework with our
mm,
system. So it's highly retrofittable,
yeah.
basically.
And you mentioned them within a few hours. So there is somebody asking about how long might it take per room, for example. Obviously, rooms vary in sizes and complexity, but is it a case of it is as minimal as a few hours? Is Yeah.
For somebody with experience, yeah. So we've
Mm.
got a lot of online videos of installation. So our YouTube channel is pretty buoyant with like ongoing retrofit examples, and remarkably, 70% of the B2C market that we service is DIY. So a huge number of customers that we sell to actually install the system themselves, which I'm amazed by. And earlier this year, the ThermaSkirt product was launched by Wix as well. So again, that was to sort of help address our DIY market, because for us as a manufacturer, we're moving more into like export and large scale commercial projects. And then really for the consumer, we're starting to put the product into places like Wix and City Plumbing to sort of divert that through a wholesaler
Yeah.
effectively. So yeah, the short answer is it could be anywhere from a couple of hours to a full day, depending
Yeah.
on how much work is needed. But yeah, it can be as little as a few hours.
Okay. And those YouTube videos on your channel, it's the Discrete Heat channel on YouTube. Is that how people would find it?
Yeah, at ThermaSkirt is
At
our
ThermaSkirt. Okay.
yeah.
Great. So I'm sure lots of people are going to look those up after. Um, Someone's asking, do you fit up in the Highlands and Glen Elg? I assume you've got suppliers, wholesale
We
across the
are we
UK,
we are nationwide, yeah.
nationwide, fab, excellent. Longer question. What is the minimum distance to be maintained between ThermaSkirt and furniture placed in front of it to prevent damage to the furniture and allow for that efficiency of heat circulation?
So the it depends really. It depends on the temperature that you're running it at. So if you're running the ThermaSkirt on a heat pump at 40 degrees, it won't matter if the furniture's touching, so long as you've not got like some 19th century Chippendale, sideboard that's worth 10 grand. There is nothing, because it's a very low intensity heat. So over that short distance of the skirting, the amount of heat that is put out is low compared to a radiator. But obviously you're stacking up the skirts, but it's more like underfloor heating. And obviously you have underfloor heating on top. You have your furniture on top of all of the underfloor. So there is no sort of specific distance required. We've done 80,000 systems, and I've not had any reports of damaged
Yeah.
furniture.
I suppose you have to just assume there's good common sense with individuals working with it in their space, like any kind of fixture or fitting in your home, it's
Yeah.
yeah, about people taking care, isn't it? So yeah.
Yeah.
All right. Interesting question about installers, plumbers, for example, knowing about ThermaSkirt.
Yeah.
So Samina says that her plumber who's fitting an air source heat pump, she assumes they won't have come across ThermaSkirt, and how
Yeah.
hard would it be for them to learn to fit it, and would they need training? I mean, you've answered that in some ways in the sense that you can support that, and you've also got YouTube tutorials and things. But is there any more you want to say on that, Ethan,
Yeah,
about?
so we have a full registered installers program. So at the moment, there's 250 installers who have gone through the training. A huge proportion of them actually are in London, because that's where a lot of our heat pump inquiries come from. Um, and yeah, basically installers can do an online module initially, and if they feel comfortable, they can go from there. And then we also host in-person events. So we have a training facility here at the factory in Manchester. We also have access to another facility down at the NSBRC in Swindon, and we also hope to run some training courses from the building centre later in the year as well. So yeah, we do a lot to support installers, and we're continually training, probably in the region of 10 per week, are going through our training sessions.
Great. Okay, it's quite a range of questions. I'm just trying to make sure I understand them as well before I put them to you, Ethan. This one I don't understand, but I'm hoping you can put clarity on it. Can you explain the microbore pipework aspect again, please? Will you need to re-screen share for that? Or
No, I think I could probably explain it. So with different sizes, the simplest way to put it is with different sizes of pipe, you can get a certain amount of energy down a certain size of pipe. So, for example, your central heating system can deliver more energy down a 15 millimeter pipe than it can down a 10 millimeter pipe. Now, the lower the flow temperature you go, the less energy that pipe can deliver. Okay, so if you run 90-degree water down a 10 mil pipe, you'll probably be fine because 90 degrees water holds a lot of energy. When you start to reduce the flow temperature per gram of water delivered or per kilogram of water delivered, the potential energy reduces significantly. And so the smaller your pipe work, the less and less suitable it becomes for heat pumps. Now, that's not to say that microbore full stop is a no for heat pumps. But what happens is that your amount of available heat capacity down that microbore pipe reduces. And in a retrofit situation, on a room by room basis, your heat loss is generally higher. So as a total rule of thumb, and it's not a hard and fast rule, but as a total rule of thumb, generally installers shy away from microbore on heat pumps because, again, as a total rule of thumb, the microbore doesn't have enough energy capacity at 40 degrees to deliver the heat required to the radiators. The point that we're making is that if you are in one of those situations where you're doing a retrofit and you have to replace that microbore pipe work, you then have to get brand new pipe work to the radiators because typically in a property you're dictated to by where the radiator has to go. So for example, if the radiator is under this window, I now need to work out how am I going to get pipe work to that radiator. Whereas instead with the ThermaSkirt, I can just start it next to the door or wherever's most convenient in the corner or wherever I've got access. So we make the disruption minimal in that instance.
Yeah, great. Slightly different from Anthony. What standard detail do you have to get past fireplaces and concrete floor slabs? So,
Okay, so fireplaces, it depends. So sometimes you have to skirt the whole room. Often you don't have to skirt the whole room. Often you can skirt half of it and still meet the heat loads required. If you do need to bypass a fireplace and you've got a concrete floor, what we actually do, which is a little bit more work, is we actually do what's called a threshold kit. And in that situation, you effectively cut a small channel to connect across obstacles because it might not just be a fireplace, it could be a doorway or could be, you know, I don't know, anything, steel pillar or something. You effectively have to make a channel to make a bridge across with the pipe work. So yes, that is more disruption, but again, you know, it's minimal. It's not the same as ripping up the whole concrete floor.
yeah, great. Now, I was thinking about this, and someone has actually asked it. What is the cost comparison with traditional radiators?
Fortunes, absolute fortunes. No, so in terms of a cost perspective, we are more akin to designer radiators, I guess. If you were going to compare ThermaSkirt as a consumer to an absolute bog standard white panel radiator, ThermaSkirt is going to be a more expensive option without doubt. So as a general rule for a consumer, it's unlikely that it's going to cost less than £400 for a room for the materials. And it's unlikely to cost any more than £1,000 per room. So typically, if you took, say, a 3-bedroom house, you're looking in the region of maybe like 4,000 to 5,000 for the materials for a full house. So again, a lot more like designer radiators. And you can also pick and choose your rooms. So for a lot of our customers, they may not want to do the entire house. They might just say, well, actually, the benefit to us is really in this kitchen diner and the master bed. So they can sort of cherry pick the rooms that they want to do the most. For developers, there's additional savings as well. So if you're going to do a deep retrofit, for example, you also have to factor in the cost of fitting and painting skirting boards, which again, you know, on a standard build can be anywhere from £15 to £20 per meter, which we eliminate. So in that situation, the gap narrows significantly if you're doing new skirting boards as well.
And building on that, you said local authorities and housing associations are using ThermaSkirt. So if there's a kind of cost comparison for them, are they sort of saying the minimum, the reduced disruption is a benefit when they're doing an analysis, or is it hard for you to get into their heads? I suppose you won't necessarily know what's in.
No, it's on a case by case basis. Obviously, every project's different, and you know that's part of the challenge of working within retrofit. That
Yeah,
it is very much like a sort of case by case basis. But if, for example, a local authority is doing a deep retrofit, then the costs are comparable because you've got new pipe
yeah,
work, new skirting boards.
the
You know,
package. Yeah.
often if they're doing things like internal wall insulation, they're also losing room space. as
Yeah,
well
that's true. Yeah.
when they do that. And so by removing the need for a radiator, you then gain back some of that room space.
Mm.
So yeah, for local authorities, at deep retrofit, it's comparable in price. Light retrofit, ThermaSkirt is going to be more expensive than just putting a bigger radiator in. But you know, obviously you get all of the benefits which I've highlighted today.
Yeah, exactly. Got to think of it holistically, right?
Correct, yeah.
And someone else is asking, and it's probably you've picked up on some of these things. When using the air source heat pump, is there a minimum length required to adequately heat a room? I mean, I assume it varies.
Yeah, it varies
Yeah,
massively. It varies on building performance. So if there's a high level of insulation, it varies on you know, flow temperature and everything. So for us, we do a detailed heat loss calculation. So effectively,
yeah,
if we calculate that this room, say, needs 500 watts, we know that of our three pipe system, this one, you know, you're looking in the region of about 6 meters of skirting, and that might just be two walls.
yeah.
Yeah, but if it's higher than that, we might do three walls or four walls. So we do a full detailed system design, just like any reputable underfloor heating supplier would.
Yeah. Thank you, Ethan. I'm conscious we've only got a couple of minutes left. There are some questions remaining, but what I'll do is I'll make sure they get to you. And also, Ethan, you did share your email address, but do you want to just say that again in case people want to get in touch directly?
Yeah, like to keep it nice and easy. So it's just Ethan, Ethan at discreteheat.co.uk.
Fab. And reminder, you've said the YouTube channels at ThermaSkirt, other ways people can kind of find out website, things like that. Yeah.
If there's any specifiers or architects on the call, we've got a full-blown CPD, which goes into the detail, way more detail than this has. If you want to reach out, our website is www.discreteheat.com.
Yeah.
Again, nice and easy. You can log an inquiry through there. And on the other side of that wall, there's a whole team of happy and willing people ready to help you.
Yeah. In Manchester, right? Yeah.
Yeah.
Perfect. All right. Well, Ethan, I'm just going to wrap up on behalf of the Building Centre National Retrofit Hub. But thank you again for your support for Retrofit 25 and for speaking today in this Retrofit Talks webinar. So thank you to you, Ethan, and to your company and your team. It's been great to learn about it. And obviously, for those of you on the call who can make it to London, come to the Building Centre, come to the Retrofit 25 exhibition and see the case study and ThermaSkirt in action. And we've got the heat on, so you can kind of feel it radiating from there. So it's great. If you can't make it, the exhibition is now live as a virtual exhibition on the Building Centre's website on our Retrofit 25 pages. If you're on the Building Centre's website, that's buildingcentre.co.uk, you can also find out about the rest of the events. We've got another Retrofit Talks webinar next Thursday with the Chartered Institute of Architectural Technologists, looking at how architectural technologists can support retrofit solutions. And then we've got lots of in-person events. They're Wednesday evenings in the Building Centre. So throughout June, we've got dates the 4th of June, the 11th, the 18th. And Ethan, you're actually presenting again, aren't you, within our innovation panel on the 18th of June. So if you want to hear more on the various topics, innovation, carbon and materials, lots of things coming up, do check out the website. Our other webinars are focusing on jobs and skills, which is obviously something that's very important and is being picked up today as well through Ethan and some of the questions that you've had as our audience. So lots going on. So do keep in touch with the Building Centre and National Retrofit Hub through our Retrofit 25 programme. This has been recorded, so we'll get it on our YouTube channel shortly. And yeah, just do keep in touch. And yeah, thanks again to Ethan. And thanks for you all for joining the webinar. Take care, everyone. Bye. Bye, Ethan.